Welcome to a presentation on the Halcyon Advanced Job Scheduler, a powerful modern application which is scalable across demanding power system environments. Recently modernized as part of Halcyon's new generation suite of products, it has been refreshed and regenerated to take advantage of the latest IBM APIs to support today's power systems. This presentation will provide an introduction to the main features of the product. Initially, we'll review a few of the configuration steps necessary to set up for defining jobs to be running on your system at scheduled times. From the main menu, I take option 42, Configuration menu. The first area of configuration is calendars. The system is predefined with a default calendar. If you want to add your own calendars to define what days you would like the jobs to run, you can do so. By taking F6 to add, I can define the name and the description of my calendar. It's initialized with all of the days turned off as non-working days. However, if I want to select some working days, the days on which my jobs will run, I have a number of ways I can do that. One is using a bulk add by taking F6. I can specify that I want to initialize just the third Friday in every month as a working day. I press enter and my calendar for 2010 is initialized. Working days could also be defined by overtyping with a Y, or deactivated by overtyping with an N, or the input could be performed in a list view. Returning back to the configuration menu, the next option to look at is the job environments. I take option 3. We'll see that on this system there's two job environments defined. The first is the default, and the second is one that I've created for my demonstrations. If I put a 5 to display against my environment, we'll see that it is a definition of the attributes of the jobs that will run within my job scheduler. So my job D, my user profile, my job queue, my output queue. So you could define multiple job environments for, let's say, a payroll system or part of your ERP system, so that all jobs with similar attributes when they are submitted can be defined easier. The utilization of an environment will be shown later in the demonstration. Returning back to the menu and then back to the main menu, the third configuration step is to look at the substitution variables. Substitution variables allow you to pass information and parameters to the jobs that you're calling from within the job scheduler. So for example, if you have to call a program and pass to that program the current period end date, we can do that using a substitution variable. A user-defined substitution variable has been entered to the system here. We'll see that it currently holds a date of 10/03/26, the current period end date, in year month day format. To change this, an administrator will just overtype with the next period end date. A different type of substitution variable uses programs to calculate a value. Moving down to the weekly name substitution variable, if I put a 5 against that, it will show me that it's calculated that today is in fact a Thursday. Again, this parameter could be passed to any program that is called within the job scheduler just by referring to the substitution variable. Returning back to the menu, now that we've considered some of the configuration steps, we can look at the groups and the jobs within the groups of the Halcyon job scheduler. Take option 5. A group is a collection of one or many jobs. For example, if I look at my demonstration group, I put a 12 against my group for the job summary. We'll see that I have 4 jobs which are defined to run when my group runs. The first 2 are just calls of regular programs. The third of them is an invoke, which actually runs a job scheduler event on another partition. And the fourth one is the create of a file on a Wintel environment. To see the details of what's below my group, I can also take F11, which will let me expand the display. Here the indentation shows me the same information, the fact that below my mn_dem group I have 4 jobs defined. Moving to the group, I'm going to look at some of the parameters behind this previously defined group. I put a 5 to display and press enter. Some of the more interesting parameters on this screen are the group type, where you can define whether the jobs will run sequentially, one after each other, or whether they could run concurrently if the job queues that they are submitted to allow concurrent jobs. At the bottom of the screen, 2 very powerful parameters, allow invoke and allow condition query. The first of those is specifying whether this group of jobs called mn_dem can be started by being kicked off by a job scheduler event on another partition or on this partition. Similarly, the condition query allows another group or another job to specify that it will not start until this job has finished, and again that could be across partitions. Moving to the next page, we see that this group is defined to have its days specified by the working days on the default calendar. There are other ways to define the days that a group will run. For example, you could specify the days of the month. For example, you could specify the 1st, the 7th, the 8th, the 15th and the 22nd of each month. You could specify just Mondays. You could also specify an interval, maybe run the jobs every 9 days. At the bottom of the screen, you can also specify the times on those days when the jobs will run. Please remember, this is defining when the 4 jobs that will run when this group runs will be active. Paging down to the next screen, I see that for my environment I've chosen the mnorman defaults. So the mnorman job queue and the mnorman output queue will be applied to all of the jobs which run under this group. Similarly, moving to the next screen, the library list and the current library will be picked up from the mnorman environment. One critical part of an advanced job scheduler is being able to see and react to problems as they occur. One of the ways we help you with that is by allowing reactions to different elements of the group and the job activity. So for example, on this group we specified that when the group completes we will send a message to the system console, which is a graphical console, a dashboard showing us alerts. And at the job level, both on completion and on failure, we will send messages to that same console. The final 2 fields on this screen define how to react if an error is found in one of those jobs. Pressing enter, I return back to the work with groups display. So that's the basic definition of my group, and now to look at the jobs below that group. Moving the cursor down to job sequence number 10, put a 5 against there to display the details. As was noted before, job sequence 10 is just a simple call of a program mnjob3. So we'll page through to some of the other screens to see what other parameters we can define against this job, job number 10. The first screen allows us to override the days that the jobs will run. So we specified at the group level that we're basing our jobs on the calendar, but you could say just for job number 10 that you don't want to run it on the last Friday in the month. But on mine, I just leave the default and I move on to the next screen. Again, We defined at the group level that the mnorm and environment will define the attributes of the submitted jobs, so we keep our defaults there, but I could, if I wanted to, override those if I want something special just for job 10. Moving on through the screens, we can see that we can also pass information between the jobs within a group using the local data area. On my demonstration here, I've not utilized this function. For job sequence number 10, I'm not going to progress through to the final screens. I'm just going to press enter. We'll see those final screens when we look at the other jobs. Moving down to job sequence 20, again putting a 5 to display the details. We have a similar command being performed. This time it's a program called mnjob4, and the other parameters are very similar. Again, pressing enter takes me back to the work with groups display. The next job down within this group is the call of a remote program. Here we will see a special job type of *invoke. This means that a job will be kicked off through the Halcyon Advanced Job Scheduler running on another partition. So on partition HAL270, we're going to look for the group mn_r_group and start all of the jobs running over there. Just jumping across to that system, we see there is just one job below the group that will be kicked off from the other partition. Looking at the definition of that group, we'll see that on the very first screen, the two final fields, the allow invoke and the allow condition query, are defined as yes, which means that this group can be started by the activity of a job on another system. From here I'm just going to return back to the menu on the HAL270 partition. Again, the remaining screens for this sequence, 30, are similar to 10 and 20, so I'll press enter here to go back to the work with groups display, and then finally sequence 40 within this group. We'll look at the details behind that. Job sequence 40 shows an example of another powerful job type, remote command processing. This is performing the creation of a file onto a Windows server. This means that the file monitor within the Halcyon Network Server Suite can be watching for the creation of this file to kick off a Windows process. Moving on to one of the later screens, we'll see that job sequence number 40 has been defined with a condition. Only one simple condition is defined here, but reading across from the conditions line, we're specifying that if on the local system a group called mn_cond and the group is at status D, the condition means that sequence number 40 will only activate when the conditions are met. And the way this one has been defined is it will only run if it knows that another group has completed successfully on this system today. Moving across the conditions line, we see that the system name we're looking for this other group is the local system. That is not another partition, but it could be another partition. We see the name of the group we're looking for. We're looking for a status, and if I take F1 to show the cursor sensitive help text, we'll see that status D means that the group completed successfully and all jobs ran. Pressing page up on the help text shows us the whole variety of statuses we could check for. The final two parameters are specifying that the mn_cond job must have completed today, and it will be looking for the last occurrence of that group. So you can build very complex condition strings based upon groups and jobs running on this system and other systems before a job is permitted to execute. Now that we've reviewed the main aspects of each of the jobs that are scheduled to run within this group, we'll run the group and see how it works together. Taking F3 to exit back to the menu. Now we can see which groups and jobs have been scheduled to run. By taking option 10, work with schedule, I'm positioned to the display for today's jobs, and I'll see that one job has already completed normally. That's the MN condition group which ran earlier today, and there are 3 groups waiting to run after that. My 3 demo groups are 2330, 2344 and 2358. By using function key 11, the display shows us the actual runtime of the jobs and the group which completed earlier. It also uses the average runtime for future jobs to calculate when they are expected to start and finish. As you can see, all of my jobs take only a few milliseconds to finish, so they always have a 0 runtime. I can collapse the display by taking F11 again, and here we'll see that I can use function key 8 to look at the schedule for tomorrow, Friday. I'll see all of the condition and DEM jobs scheduled to run tomorrow. If I page down with F8 again to Saturday, I can see that none of my jobs are scheduled to run on Saturday and Sunday. Moving back to today, I have a number of options I can perform for the jobs which are waiting to run. For example, I could hold them to stop them running, I could change their runtime, and I can release them if they were previously held. To see my demonstration group in action, I could change the runtime on the first of those, but what I'm going to do is I'm going to run an ad hoc job and make it run now. So I use function key 6 to add an ad hoc job. I can then pick out the group that I want to run now by taking F4, selecting my demo group, press enter. I can specify that I just want 1 or 2 or 3 or all 4 of the jobs within this group to run, but I'll choose all of them and I'll press enter, and we now see that that job has appeared in an ad hoc state. Moving to the Enterprise Console, our dashboard of alerts, we can see the completion messages for each of the jobs that was scheduled to run going through. The third job, the running of the job on another system, has completed, and shortly the job to write the file to the Wintel server will also complete, and a message will be sent to say that the full group has completed too. Here we see the completion message for the group and all of the 4 jobs as well. The Halcyon Enterprise Console is not only used for alerts from the job scheduler, but from our other modules as well. Whether it's messages, whether it's audit journals, whether it's system events, can also come through to this screen. Moving over to the HAL270 partition, if we go into the work with schedules here, we'll see that one job ran to completion, and by using the F11 key to expand, we can see that it finished successfully. So the job which was kicked off by the demo group on the other partition has completed successfully. Back on the original partition, we can go back into the schedule and see the jobs that ran. By using F11, we can expand out to see the jobs below the groups. Over on the right hand side, we can see that the remote system name of HAL270 and the remote IP address of the Wintel server are displayed for our information. A number of other options are available to help you interrogate what happened and maybe change how it runs in the future. For example, by taking option 13 against the group and pressing enter, all of the messages related to the running of that group and the jobs below that group will be displayed. By taking function key 23, I can see further options. For example, option 15, statistics. If I enter a 15 against the demonstration group and press enter, it will show me a window with the completion times, the run times of all the jobs and the total for the group. And as you can see, mine is a very fast running job and group. If I want to make changes to the group or to the job, I don't have to go back to the menu and back into the maintenance program. I can do it from here by entering a 20 to work with the group or job from the item on the schedule. So I get into the maintenance program, or if I put 20 against the job itself, it takes me straight to the maintenance for that job. This is a very powerful display, allowing us to see what has happened and what we're expecting to happen in the future. We can see the expected run times of the jobs scheduled for later today. We can even see if, based upon their average of run times in the past, they're going to overrun into the time slot allocated for other jobs. If they do, you can then change them or hold them so that they run in the correct way. Returning back to the menu, we'll just look at a few more options before the completion of the demonstration today. First, returning to the Work with Groups program, we've focused on the MN condition and the MN demo groups, but as you can see below that, there are groups there beginning with the Z. These are example groups and jobs that you could utilize to build your own groups and jobs. So for example, the one at the bottom of this screen, the every 10 days interval, if we put a 5 against that and press page down to go to the second page, we'll see this has been defined as an interval type schedule where it's going to run it every 10 days. If you have a similar job you have to run every 10 days or 9 days or 11 days, this is a good example of how you would define that. You can utilize this ZDM group and copy it to your real group. Paging down, another useful group would be the every Monday group. If we put a 5 against that and again page down to the second screen, we'll see that the definition for the run days is based upon the days of the week, and the only day of the week that's specified is a Monday. We'll see over on the right hand side in the middle of the screen we could also specify the first, second, third, fourth day of the month, or even the last day of the month. So there's a lot of flexibility on how you define when the jobs run. Returning back to the menu, option 1, display message log. Reading from the bottom upwards, we can see all of the various activities that were performed in the running of the DEM group. Paging up, we'll also see that maintenance changes are also tracked within the system. We can see 3 maintenance records displayed on the screen. There we have an audit trail of a change that was made to the system. Going into the reports menu, we can see that there is also a print message log, so the information we've just been looking at on the screen is also available on reports too. Another useful report is the print schedule. Taking option 10, we can then specify what days we would like to print the schedule from and whether we want basic or job status information. So this is very useful to produce a report of what's going to be running or what has been run. Moving into the Utilities menu, there are a number of other options to talk about. For example, option 1, Event Status. Event processing is a way of defining that a group only kicks off based upon other events on the system, rather than the conditional processing attached to jobs. For example, if we put a 20 against CDM sequence 2 and press enter, paging down we'll see that the start time for this job is actually based upon conditions. Paging down to the next screen, we see that the timing for this group is only if the sequence 1 group is complete. So it will wait on hold until the sequence 1 group is complete. Option 2 on the Utilities menu relates to captured jobs. To help configure existing submitted jobs in Halcyon's Advanced Job Scheduler, a capture mode is provided. When this is active, the submit job command is intercepted and information is collected and used to build groups and jobs. This will help you with populating the groups and jobs within the Halcyon Advanced Job Scheduler. Similarly, if you have entries within the standard IBM Job Scheduler, we provide a command, convert job schedule entries, which will allow you to import those values from the IBM Scheduler into the Halcyon Advanced Job Scheduler. And finally, on the Utilities menu, option 20, Output Schedule, is another version of generating the schedule into a different format. Here we can specify that the schedule of the jobs to run is created into a stream file. You can specify the location and the file options for that stream file, so you have it in the right format for opening by a spreadsheet application. Thank you for your interest in the Halcyon Advanced Job Scheduler. If you are new to our product suite, you may want to download a free trial from our website, or contact us or one of our partners to arrange a demonstration. Thank you again.